Good day, my name is Antonio Johnson and I'll be demonstrating my storage tank heater solution for assignment number 2. So the setup is quite simple. We have a start stop control. We are using a deadband, so we are trying to monitor the temperature between 35 to 40 degrees. We have done calculations to get the equivalent hex values, which is what we have here. So in 47 and the 55 are the equivalent hex values for the 35 and 40 degrees Celsius respectively. We have our heaters, our valve 1, mixer valve 2, our timers, etc, etc. So without further ado, let us go right into it. So we're going to simulate it because we would not have connected the physical input, so we're going to pretend as if we had actually done that. So we'll go to simulation. Now simulation is on. Now to manipulate each of these relays or contacts, we are going to go into memory and actually change the numbers that are there. To do that, we have to go to online, monitor, check the memory access areas, then click monitor. So now we can actually manipulate what is there. The first thing you need to do before you even attempt to manipulate the memory locations, you have to go to the tool here, so that changes the display into being binary. That way you can actually change the bit for each register. Each of these columns are registers. So if you notice, the start is located at 000.0, so we're going to change that to a 1. Just double click and click OK. We're also going to set the, let me just make sure I'm telling you the right thing. Yes, we're also going to set the lower level switch to 1, which is located at register 3 in that row. Alright, so we expect, based on the problem definition, that the valve 1 should turn on and the heater should turn off. So you notice it says run, so that means the system is on. Let us see. So we have to put the value that we want, the temperature that we want. So we're putting so right now there's 38. So 38 would have represented a temperature below 35 degrees Celsius. So that would have caused the system to be, the heater to be on, which is what we're seeing here, and valve 1 to be off. So let us change the temperature to something that is above 40. Go here, we change this to 56. You notice now that the heater is now off, valve 1 is on, and the mixer is on. Now let me just resize the screen a little bit. Now pay close attention to this. When I change the value from 56 to 38, valve 1 turns off but mixer 1 stays on temporarily. That shows that the timing circuit is working. Let us try that again. So we're going to set the temperature to something above 40 degrees Celsius. Note that valve 1 and the mixer is on. Changing it, the temperature down to 38. Valve 1 turns off and the mixer remains on. So we are able to verify that that is indeed working. The other thing that we want to test now is when the lower level switch is off, we're expecting that the valve should turn on regardless of the temperature. So let us set that to 0 here. See that this line here is being triggered, and so the valve 1 is on. So we have tested all the conditions that are there, and we have seen that the system is working as expected. There were various upgrades that could have been made to the system. For example, as you can see here, the heater and the valve 1 is on, which is indicating that the system is trying to both heat and cool the liquid at the same time. This could have been alleviated if we had changed the range of temperatures that were used to trigger the valve opening and closing. So otherwise from that, the system is working as described, and yeah, thank you for coming to my presentation.